Today we discuss the Paterno Buchi reaction, which is the photochemical reaction. In this 2 plus 2 cycle addition reaction, the reactant or Paterno Buchi reaction is important thing is carbonic compound and your olefin or alkene take a part. But your carbonic compound in triplet excited state and olefin formation of the bond at ground state. Then after the product is formed is called as oxygen. Let's see the example. Our carbonic compound, then olefin. And here our olefin, or it is also called as alkene. Let's see photochemical condition 2 plus 2 cycle addition. Then formation product is oxygen. Let's discuss the mechanism. How can the product is formed oxygen? Which state is involved in Paterno Buchi reaction? Okay. Let's see the mechanism. We know that our carbonic compound which undergo photolysis after absorb the light, then it undergo singlet excited state, homolytic cleavage, formation of diradical species. Internal system crossing. Internal system crossing in which it undergo triplet excited state. Okay, but many of students saying that both singlet excited state and triplet excited state are same structure. What will be the main difference? Before, after the homolytic cleavage, formation of diradical. Here, carbon oxygen double bond is break. At that time, formation of diradical or two radical. Then spin, what will be the spin? That radical is inversion. In your singlet excited state, that spin of both radical are in opposite direction due to the bond breaking process. After it undergo internal system crossing, their spin in same direction. It may be upward direction or downward direction. At this stage, your triplet excited state, their carbonyl compound react with alkene, olefin compound. Okay. Let's see the second step. Up to the triplet state, formation of olefin radical. olefin compound undergo the photolysis. Then formation of radical. Here one bond break and other bond is same. Diradical species. Diradical ground state. It reacts with triplet state of our carbonyl, triplet state of our carbonyl compound here, which is upper direction in formation of bond between this oxygen and this carbon radical. Why not this carbon radical is take part first? Because oxygen radical is highly unstable, so it reacts first in carbonyl compound diradical system. After that, we got biradical or diradical species. Which direction is same direction. So how can this bond form between this carbon radical and this carbon radical? They undergo the spin inversion. After the spin inversion, this upward spin is changed to the downward. Then after formation of bond, and lastly we get our product, which is oxygen. Okay. After some time, we discuss the example. Let's see the second example of Paterno Buchi reaction. What will be the product? We already discussed the mechanism. This photochemical condition, it undergo 2+2 cycloaddition. The product is oxidate, formation of radical. Okay. Then the radical species. Then after here also radical formation. Which radical is react first in alkene or olefin? This radical is highly unstable, so it reacts first with oxygen, and that the formation of the product is pH. Okay. Which react radical first? It's depend on stability of the radical. We know that. Tertiary radical is more stable than secondary, then primary, and lastly our methyl radical. Okay, so here methyl radical react first because it is highly unstable as compared to this radical. It is tertiary radical. Okay, let's see the third example of Paterno Buchi reaction. In this reaction, two product formation possibility. Which product will be major and which product will be minor? How can decide it? First, we undergo the mechanism. What will be the major product form, and how can both product is formed? Let's see the mechanism. We already discussed our carbonyl compound undergo the triplet excited state in Paterno Buchi, then formation of radical. So here two radicals is formed. After that, the species which are also formation of radical. Here formation of two radical, which is a tertiary radical and secondary radical. Which radical is more stable? That thing is important in this example. Due to the this product will major and which product will be formed minor. In this reaction, your tertiary radical is more stable. Tertiary, secondary, primary, and methyl radical. But this secondary radical undergo the conjugation. This double bond is stabilize this secondary radical. So it reacts after the tertiary radical. First we react tertiary radical, this oxygen radical. Then formation product. Here, like that. Then after these two radicals is recombined, and then formation of oxygen. Which is our major product. Now we see the how minor product is formed. We know that oxygen radical is react with secondary radical, then these two radical again recombine. The formation product is oxidate, but it is minor product. Okay, why it is minor? Because that stability of our alkene group. In here, tertiary radical is formed, but in your secondary radical is stabilized due to the conjugation. So it reacts second and first react with tertiary radical. Okay? So thank you.